And solving equations with logs, this is sort of the point of everything that we've been doing. And again, keep in mind that this is going to get more complex when you hit it next year. I don't tell you that to scare you. I just want you to know there's more coming, okay? Because even by the end of today, you might be looking at this and saying, like, well, why did we spend all this time learning this? It's because it's going somewhere, okay? Today we're kind of putting everything together that we've learned about logs. We're going to talk about how to rearrange them into exponents. We're going to talk about using the properties. We're going to talk about using change of base property to solve for a missing value, to solve for an x, okay? The problem with these equations is, you know how normally with equation solving there's a very set process? First step you do this, second step you do this. With log equations, because there's so many different forms that they could be in, you have to be a little bit creative. You have to be a little bit willing to say, hey, let me try this and see if I can get anywhere. And then if you can't get anywhere, going back and trying it a different way. Okay? So let's try these. And again, I put the note on there. You have to be creative because you have to kind of think about what do you already know about these. So in that first one, I have log base 2 of 3x equals log base 2 of 6. Does anyone have any thoughts about something I could do with that? Emily? Okay. Like into proportions, you mean? Kind of. I sort of could do that. Austin, what's your thought?
Divide each side by 3.
Okay. I am going to do that. However, do you see that they're both a log of 2? Log base 2?
I see that.
What do you think I can do if they're both log base 2?
Cancel them out.
I can cancel them out, yeah. So Emily, technically your way would work. I think it would be more complicated. Okay. I would take the log base 2, and you can do that if both sides are exactly the same log with the same base and there's no other numbers floating around. See how here all I have is a log base 2 and a log base 2? I'm going to do this. I'm going to cross off log of 2. Oh, if I can get my pen to work. It is echoing back, yeah. Sorry, I don't know how to fix that.
Turn your volume down on your iPad.
I did. Okay. I'm going to cancel off log of 2. Then what does my equation look like? Easy from here, right? What does it say?
3.
Yeah. Now it just says 3x equals 6.
X equals 2.
It does. Divide by 3, divide by 3, and I end up with x equals 2.
Oh, you can cancel.
So does that same thing work in the next one?
Yeah.
Okay, so in the next one I have log base 5, log base 5. One equals the other. And so now I just have negative 2a plus 9 equals 7 minus 4a. A tougher equation to solve, but still solvable, right?
Right.
Okay. Okay, so negative 2a plus 9 equals 7 minus 4a. What would you do to solve this? Any thoughts?
Subtract 9.
Okay, I'm hearing a bunch of different things that would all work. I'm going to go with add 2a. And that's going to give me, I'm going to move over to the side here. This is going to cancel, and now I'll have 9 equals 7 minus 2a. Okay, now what? Minus 7. Two equals negative 2a. Divide by negative 2. Divide by negative 2. And you end up with negative 1 equals a. So not so bad once you got rid of those logs. Now here's the problem in the next one. Is that your first instinct is going to be to cross off all those log 9s, right? That doesn't work. Okay? The log base 9s. Because you don't have one log equal to another log, you have 2 logs equal to a log. What I'm going to have to do is I'm going to have to combine these logs. Okay? Which I can do if you think back to those properties that we've talked about. Okay? If I have subtraction there, it would be division, right? So this, here, let me move this up some. This side here, I could rewrite as log base 9 of x divided by 4, right? Using those properties that we've talked about. That's what we were just doing in the warm-up where I said simplify, so I can put those together. And now I can say that equals log base 9 of 12. And so now that I'm at a point where I have one log equal to another log, now I can cross them out. So now I can just go to x over 4 equals 12. And how do I solve from there?
Multiply.
Good. So x equals 48. Questions on that? Let's try some more. That first one, log base 3 of x equals negative 2. The problem with that one is I don't have another log on the other side, right?
No, I think
What do you think?
no. Do we have to do like
What's
the
that?
thing we've been?
Okay, I could move the 2 to the other side. The problem is that still wouldn't be a log, so I still wouldn't be able to combine it with the log 3x.
Do you wanna do the thing we were doing last night? Like, would that make-
Okay, good thought. The problem is, if I were to do that, what I would really be doing is log of x divided by log of 3, and that's, you know, I guess you could make that work. You might be able to make that work. That's not how I would go about it, but that might work. What was the very basic thing you learned about logs? Like the very earliest thing that you learned? Emily? We could write it in exponential form. Yeah. What would this look like if I were to write it as an exponent instead of as a log? What to the power of what? Nope. 3 to the power of... Which number in a log is the exponent? The answer. Yeah, the answer is this here is your exponent. So it would be 3 to the power of negative 2 equals x. Well, now look at how easy that is. Now I just need to know what's 3 to the power of negative 2. Oh, come on, what would it be as a fraction?
9 over 1.
Not 9 over 1. 1 over 9, yeah. Okay. In that next one, any thoughts about what to do first? Stephen? Okay. So if you've got a log, but other numbers floating around there with the log, like this negative 10, the first thing I would do is get rid of those numbers that are next to the log. So I'm going to take this negative 10 and move it to the other side. So add 10, add 10. And so now my equation would say log base 3 of n plus 3 is equal to 0. Well, now this is kind of like the one above, where I just have one log equals a number. What did we do up here? We wrote it in exponential form, right? So what would this look like in exponential form? 3 to the power of 0 is equal to n plus 3. This whole thing is what it would be equal to. What's 3 to the power of 0? 1. So 1 equals n plus 3. Now what? Subtract 3. So n would be negative 2 for that one. Doing okay with that? Okay.
Oh, yeah.
Let's try one more. Look at that bottom one. Negative 6 log base 3 of x minus 3 plus 5 equals negative 19. Just like every other equation solving thing we've ever done, Just like every other equation solving thing we've ever done, the first thing I would do is get rid of anything that's outside of the log. What do you want to get rid of first? Whoever's rocking out, turn it off.
It's not turning off.
Okay. What do you want to get rid of first?
Add the 6.
Nope.
Add.
Okay, the 5. Let's subtract the 5.
6. Nope.
Hey, I appreciate the participation. So now I have negative 6 log base 3 of x minus 3 equals, what would that be, negative 24. Okay? Now what?
The log and
Not yet.
divide negative
Gabe, what do I still need to get rid of?
the negative 6.
The negative 6. Jace, how am I going to do it?
Divide.
Divide. Yep, that's negative 6 times log of 3. So I'm going to divide by negative 6, divide by negative 6. Yep. So now I have log base 3 of x minus 3 equals positive 4. Now, Gabe, what am I going to do? Exponential form. What's it going to look like in exponential form?
3.
Yep. 3 to the 4th power equals x minus 3. What is 3 to the 4th power? 81. Yep. I'm going to move up to the side here. So 81 equals x minus 3. Let's add 3 to each side. And you end up with 84 equals x. Feel pretty good about that?
Yep.
A couple more to go. We're not good.
Alright, let's do it.
Okay, some guidelines. Because again, sometimes you kind of just have to mess around with it until you get something that looks like you can work with it. But in general, if you have just one log somewhere in the problem, I would move it around to where you have the log by itself on one side and a number by itself on the other side, and then convert to exponential form. That's like what we were just doing. Okay? So we made it, if there were numbers outside of the log, we got rid of those numbers, and then once we had just log of something equals something, rewrite it as an exponent and try to solve. Okay? If you have 2 logs, but no other numbers, so if you just have 2 logs that are floating around in the problem, I would make it so that the 2 logs are equal to each other, and then just knock the bases off and solve what's left. So that was like that first group that we did. If you have 3 or more logs in the problem, and I'm going to add something onto that, 3 or more logs, or 2 logs with other numbers. So 2 logs, but then some other numbers floating around. I would use your properties to combine your logs. Okay? And you can combine logs until you end up with just 2, and then you could do this, the 2 logs with the same base. Or combine until you have just 1 log with another number, and then you could do it this way. Okay. Questions on that? You're gonna catch that? I'll shut that in just a second. We have one more set of examples, I think, to do. Okay. One more thing to show you. And this actually is similar to what we did yesterday. Okay, you saw this yesterday, gentlemen. Okay.
April Fool's.
If you have an equation that has an x up in the exponent, if you have an equation that has an x up in the exponent, what you can do is take the common log of each side. Well, first I would, let's look at what this says up here. So get yourself to an equation that just looks like this. Sometimes you'll have other numbers like in front of the a, or you'll have something added on. You want to move all of that stuff away, so you just have something to the power of x equals something. Then you can take a common log of each side and move the x down in front of the common log. Okay, so that's what you saw. Do you remember this example? We did 5 to the x equals 12. Common log is base 10. Yeah, the one that your calculator can do. Remember, we took a log of each side like that. And then we moved the x, this x here, down in front, the exponent. And then what did we do?
And then we did the thing.
What thing?
The thing we did yesterday.
If we were trying to get x by itself, we would divide, right, by the log of 5. So then we would divide by 5. And in this one, we ended up with 1.54. There should be division bars here. Okay. That's the exact example we did together yesterday. Okay, but that's how you would handle it if you were looking at an equation that had x's up in the exponent like that, is I would take a log here, move this x down in front, and then divide by this log on the other side. Okay? Let's try a few of those. So 3 to the power of x equals 10. What's the first thing you're going to do? Log on each side, yep. So log here, log here. And then this x is going to move down in front of the log. I'm just going to do that kind of all in one step. Because remember, when you have an exponent, you can shift it down in front. So now I would have x log 3 equals log 10. And then if I were trying to get x by itself, what would I do? Divide by log 3, you got it. This is kind of like that change of base formula, except it's not quite in the same format. So here you would end up with, I'm going to let you do the math on that. Drew?
You start off writing that as log base 3
Sure. Yeah. Yeah, so you could take that 3 to the power of x equals 10 from the beginning. This is what Drew's saying, is you could write this as log base 3 of 10 equals x, just using what you know about exponents to logs and vice versa. And then if you were to do the change of base formula, wouldn't you end up doing the same thing? Log of 10 divided by log of 3. So if you wanted to do it that way instead of doing this process, that's fine with me. Okay. What do you get for that? 2.09. 2.09. Okay. What about something like the next one? 5 to the power of x plus 3 equals 59. Good. You do have to minus the 3 first. So that's going to give you 5 to the power of x equals 56. So yeah, the first thing I would do is get rid of any other numbers besides the exponent piece. So if you've got this 3 floating out there, get rid of that first. Okay. I switched my color scheme here. So I would do, I know. So I would do log here, and so this would end up being x log 5. I keep holding it over the vent and the microphone's freaking out. Equals log 56. Then I would divide by log 5 on each side. Okay. So yeah, if you're really comfortable with that conversion from logs to exponents and vice versa, this is a great way to do it. This up here. Okay, just rewriting it as a single log and then using change of base. What is log of 56 divided by log 5? 2.5. 2.50. Okay. So here x would equal 2.50. What would you do first on the next one? Okay, yeah, I would get rid of this 2 first. So divide by 2, divide by 2. Be careful. I get a lot of people who want to multiply this 2 and this 5 together and make it a 10. Remember that you can't do anything with the 5 because it's got the exponent on it. Okay, so you can get rid of that 2, but the 5's going to stay put. And so now this would say 5 to the power of x equals 15. Log. I would write this as x log 5 equals log 15. Then what? Wyatt? with me over there. Okay. Then what?
Turtle.
Divide by log 5.
Log 5.
Yep.
Equals 1.6.
Thank you.
83. It's funny because I'm not sure.
Good?